Hello there, I am Edwin Mascarenas and today I'll be solving sum number 63 of H.C. Verma part 1 of work and energy. H.C. Verma. The sum is, in the given question we have been asked that I'll be solving part A today. Well, the question is, there's a chain of length L and mass m lying on the surface of a smooth sphere of radius r which is greater than L, with one end tied to the top of the sphere. And in part A we have to find the gravitational potential energy of the chain with reference level at the center of the sphere. So here I am drawing a 2D figure of the sphere. This is the sphere, or looks like one, and this is the chain. It's on top, and this is, I have joined the top end of the chain to the center of the sphere, and this is the reference line and radius r. So the first thing which comes to one's mind when one thinks of finding the gravitational potential energy is mgh. That is the first thing which comes. But in this particular case you will see that you can't just apply mgh to find the gravitational potential energy of this chain. The reason being that although you know the mass of the chain, you know the length of the chain, you can easily find what is the height of the center of the chain from the reference level, but the problem is the height of every small bit, every link. You see there are links in the chain. The height of every link from the reference level is different. As you will move upwards, the height will keep on changing. So the way to do this will to get the answer, to find the answer of this, the easiest method is you find the gravitational potential energy of a small portion of the chain, and you keep on doing a continuous addition from the bottom to the top, and which will result into the net gravitational energy of the potential energy of the chain, or in simple terms we integrate it. So for that I consider a small bit of the chain of length dx. This is dx. I join both the ends to the, I'm joining to the center, and this small little angle is d theta. Okay, so the mass of this small portion, so mass per unit length of the chain into length of that small bit, so this will give you the mass of that small portion, and multiplied by gravitational acceleration g and multiplied by h will give you the potential energy, gravitational potential energy of this small bit. Now here h, now to find the height I drop a perpendicular to the reference level, and suppose I call this theta. So as you know, sine theta is h upon r, so r will be, h will be r sine theta. You substitute that value here and you'll get the m by L into dx g r sine theta. Okay, now as you know, angle is arc upon radius, so d theta is equal to dx upon r, so dx equal to r d theta. Simple enough, you put this here. So what you get, the gravitational potential energy of this small little portion is m by L r square g sine theta d theta. Now we integrate it and we put the limits. Now the limits are the second important portion of the sum. That the upper limit is obviously pi by 2, you see this line, so it's pi by 2 or 90 degree. And the lower limit, that is, I just join this lower end here. Okay, so you want to find this angle. Okay, now suppose this angle, this entire thing is alpha, so alpha equal to L upon R, and this the required angle is pi by 2 minus alpha, which is equal to pi by 2 minus L by R, and here you have your lower limit, so I'll put that here. And once you integrate it, putting the limits, you will get your answer as m by L R square G sine L by R. There you go. This is the gravitational potential energy of this chain on the sphere. You can have a closer look.